have science and engineering, and everyone has scientists works understand, and engineers solve problems, okay? And we provide science foundation to engineers, and they provide new challenges and new questions. And this happens in any science: natural science with engineers, life science with medicine and bioengineering, and social science with policies. Based on experimentation. And of course, people say those were real science and put a question mark. Why the hell we have a Nobel Prize, for example, okay? But here it comes, lab and natural experiments. So now we have real experiments. So we can talk the eye to the other scientists. So it's pretty much what engineers do, no? So what this causality in science is about engineering of control. You have inputs, a control, and an output. And social science, we have agents' decisions, policies, and social outcomes. That looks pretty much the same thing. Here's natural experiments coming. I'll put natural experiments, what both of you mentioned. I think each one's different type of experiments have different comparative advantages. So you just have a policy, or you have placebo, and that's it. You play with it and see what happens with that. So now in macro, we could do the same thing. We have individual actions. People make decisions, these little A's, no? Your assets or whatever. Then we have policies, and we got an outputs. Policies affect the aggregates, which is the capitals, A's, and we go from one state, A, little, A big, and S, which is exogenous state, to A prime and primes. So, but this, when agents make decisions here, the households about savings and leisure and all that stuff, they have to have a perceivable motion about how the economy works. You have to have a perception about the interest rates, whether you buy a house or not. Okay? That's part of it. But that's exactly where we stand apart from other science. Because before it was clear, you put some inputs and policies, and this is like this, always from the past to the future, in causality and in control. But now we have this feedback effect of expectations. Okay? And agents are not stupid. Sometimes they think, well, is this a policy or just a placebo? They're talking about things, but maybe they don't do them. And of course, that will affect what we decide and even the effect of the policies. So the reason I got involved with doing experiments is because I think that's exactly where lab experiments come in, to understand much better this stuff. Okay? And there are good reasons that it's going to be difficult to do it with traditional econometrics or with other things. Okay? So, oh, I missed to deal with this. Sorry? Yeah? Okay, that's okay. I think it's clear now.
You're experimenting.
Yes. So that's the whole idea. We go from the perceived law of motion to the actual law of motion. Learning is exactly about that. Learning theory is about understanding more this move from what people perceive to what we do. When in our case, then there is this aggregation element that we're talking. So we have used learning theory and this called stability. I'm not going to talk about that, but just for you to know. As a way to have, in many cases, we have many equilibria in our models. Okay, so one typical, which I worked a long time ago, was this. I mean, you can think of money. We're holding money, fiat money, because we have the perception we'll have some value tomorrow. Otherwise, we will not have it. Okay, but that, if you had to work through these models, typically generate, we have many rational expectations, and particularly, so that's like a typical economy where the government finances some expenditures printing money, and we'll have like a steady state, this is inflation today, inflation tomorrow, another steady state which is high, but many, we call it continuum of paths going up there. So that was sort of puzzling because we liked our theories to have predictable power. Here says all kinds of things can happen. Actually, very counterintuitive things can happen, which I'm not going to have time to explain. But Learning theory goes the other way around. It's like the mirror. Then you have paths that will go down here. Alan Marcel, Wisdom, started work on it, for example. But then the question is how we tell those things apart. Okay? Well, I did a lot of experiments with Sam Sander, and here they are. They're always here. Never one of these things. This is normalized over a lot of experiments, always here. But then, of course, you can use these that not only to understand where we can, which kind of equilibria are more learnable, are more likely to happen, but also then to design policies. For example, since here the problem was the high inflation because we had seigniorage. Okay, one thing sometimes we recommend is that you reduce the seigniorage, as we do with the ECB. Then this equilibrium goes down. Actually, that one will go up, like this, goes like this. Or some people recommend, like here in Europe, that you constrain the ECB from using seigniorage. So you put some fiscal constraints on the deficits and so on. Well, in this world, if you were to put, so you want to see learning can help you with policy design. So it is with George Evans and so. So if we do the rational expectations, the things go even worse. I mean, it just, spend too much time. But the whole thing is that it doesn't make any sense to impose a fiscal constraint in this world in the rational expectations equilibria model. However, it's just the other way around with adaptive expectations. Adaptive expectations mean people just look at the past to figure out the future. Okay? Expectations. And then we can just do this in the experiment. And this is going through the experiment. We target and we just go there. So we just go exactly where we want by reducing slightly making it tighter, the constraint on the deficit. Okay? So that's exactly the case where the fiscal policy works. So we can figure out that one in the experiment in the lab. Difficult to do its other plans. Well, then what about other strange things like sunspots, things that have nothing to do with reality having an effect? People worry a lot about that. Actually, you can even show that that might be learnable. So that's a lot of the worry, because some strange things happen very nonlinear here. But we put it in the lab. We never saw that, not out of the blue. Because it requires people coordinating beliefs about some kind of sunspot. We don't see that. However, then we just did something else, which is the very Pavlovian stuff. So what we did is have a real effect. So it was a shock that happened at odd periods, even periods, different shock. People didn't see that, but they saw the flashing lights as they said before. But now they maybe figured out that flashing lights said something, because we stopped the shock, the real shock, and then this sort of continuous. That happens here, and so on. So what's the bottom line here? We don't see these effects, except that the people had to expose. So that tells you that sometimes you do the same policy in different countries. It's very different if people had the common experience of living in Argentina with very high inflations than not. A regression will tell that those countries are using very different policies. It's the same policy, but we have these different feedback effects, okay? So that's an example where there was nothing, put the shock, and then we're just gone. So people have looked at that, trying to get this type of effects. This is a recent paper. So this is a model where you have the productivity is like have multiple equilibria, all rank, because your productivity depends on the other firm's level of employment. So you can just put it up in a model where you have equilibria where you can have higher level of employment, low level of employment, and something in between. And then they make the announcement, simply say, we think it's going to be high employment, which is just an announcement, it has nothing. And sometimes people coordinate. Okay, it takes a while. Sometimes people coordinate. Sometimes they do. Good job. So it's like the high employment, low employment. But other times, nothing. People just realize that it's more important what the other guys are doing rather than this guy babbling about being high or low. So that's the case. Okay. But I think more interesting probably than this is to understand one is likely to more easy and easier to learn and faster. So canonical model we use a lot in learning is a model that looks like this. The price of today depends on the expectations of the price people had. That's a linear one. So that's, so if we put the B between 0 and 1, this is the so-called Lucas asset pricing model. Because the price of today of the asset depends on how much you think you're going to be selling it tomorrow. But, and that's how all the learning literature started in economics, started in agricultural economics. In agricultural economics happens that you have to figure out what you think the price is going to be before you decide what to plant and how much to plant. But once you have planted, you are stuck. But this means that the B is negative. Because if you thought that the price was going to be very high, and then they just will go the other way. So, but anyway, so you just have one rational expectations. It doesn't matter. The rational expectations is the B star. It doesn't matter whether it's one model or the other. It's the same thing. Okay. So here we might have some perception. This will be the actual law of motion. So as we move from the perception, let's say that we think that the price is going to be better, to the actual law of motion. And there's this mapping, and that's how we talk about this stability I mentioned before. You only need this B to be negative. Excuse me, less than 1, so the ratio B. And that's it. That's, in both models, that's true for the asset pricing or for the cowboy model. So that's good. That's both learning. But they have different properties. One is positive feedback. The other is negative feedback. So here is an interesting experiment that those guys have done recently. So you do the same model, and now what you're going to change is the fundamental price, OK? So it's going to be an unexpected change. And see what happens. Well, this is it. This is when you change with positive feedback. This is when you change with negative feedback. They learn eventually because we knew that it was learnable, but it takes a while with positive feedback. Okay? Because everyone is moving just in the same direction. Instead, you get crash when it's negative feedback, and you learn immediately. You get burned. Okay? Well, this has implications because, okay, this is like comparing again and so on. This is the price-dividend ratio in US. That's the asset pricing. So we expect here exactly to have this positive feedback. Yes, so we can just then use learning theory to look at that. And that's a recent paper by Albert and, what is Albert? Jesus, not here. We mark, okay? So here they had just simulated a more sophisticated learning model to do exactly that. But what is behind this sophisticated model of Klaus and Albert and Hans is exactly that positive effect. And that's, when we understand this, is in the lab, not in the computer. But you need a computer to do that and the model. So use the lab to study feedback mechanisms, not to validate models. There are a lot of papers trying to say, they think that the task of the, okay, that's my clear position, that they do. What do we do in the lab? Oh, I look, the Neo-Keynesian model, I put it in the lab. Or I put it in the lab and see, no, waste of time. However, to understand basic mechanisms, that's very important. And that's where the comparative advantage is. Okay? So that's it. I think we understand incentives, we understand general equilibrium, we understand mechanisms and contract designs, and we have to better understand perceptions and these feedback effects. For this, the lab can help. This is true in the macro, it's true in the real life too. I look at the newspapers, made me think about this book by a psychologist.